Okay, so next question, question number 5. We need to prove cube of a number is in the form of 9m, 9m plus 1 or 9m plus 8. Cube of a number. The previous question was square of a number. And now cube of a number is in the form of 9m, 9m plus 1 or 9m plus 8. So I want to explain the meaning of the question first. So if you take the cube of a number, let's say 27, this is the cube of 3. Or if you take 4 cube, that is 64, or 5 cube, 125, any cube number, it will always be in this form. So if you look at 27, is it a multiple of 9? Yes. So I can write this as 9 into 3. So it's a multiple of 9. What about 64? 64, is it a multiple of 9? No. 9 sevens are 63 plus 1 will give us 64. So 64 is in this form, 9m plus 1. If you look at the next cube number, that's 125. It's not a multiple of 9. Neither is it in the form of 9m plus 1. So 9 into 13 is 117. 117 plus 8 is 125. So it's in the form of 9m plus 8. So whichever cube number we take, it's in this form, and that's what we need to prove. Okay. So in the exam, you need not write all this. This is just to explain the meaning of the question. So how we start solving is the same format according to Euclid's division algorithm. A equal to BQ plus R. Okay. According to Euclid's division algorithm, A is BQ plus R. And we know that R will always be greater than equal to 0 and less than 3. So here, if you look at this question, the coefficient of m is 9. Now, I had told you that the question will give you the hint of what is the value of b to be taken. So here, the coefficient here is 9. So there is a tendency to take the value of b as 9. But I have taken b as 3 here. The reason is, if you take b as 9, then what happens is r will be greater than equal to 0 and less than 9. So possibilities of r will be 0, 1, 2, 3, 4, 5, 6, 7 and 8. So we have 9 cases to discuss, which will become too long and the calculations are going to be very complex. So what we can do in these type of questions is, you can take a lower factor of that. So we can take 3. Okay. So I have taken b as 3. So that is why we have taken b as 3 in this. So if you take b as 3, then r values are now less 0, 1, 2. So we can easily discuss 3 cases, r is 0, 1 and 2. Case 1, we are taking r as 0. So the value of a becomes 3q. A will become 3q because instead of b, we are replacing 3. And plus 0, no need to write. Then as per the question, we are going to cube both sides. So when we cube now, this will become a cube. And when you cube 3q whole cube, that will become 27q cube. 3q whole cube will become 27q cube. But according to the question, we want it in the format of 9s. So what I'm going to do, I'm going to split this 27 into 9 into 3q cube. And just like we did question number 4, 9 into anything will be a multiple of 9. So the bracket is replaced with m. So what happens here? A cube is 9m. So the value of m is 3q cube here. Understood this? Then we are taking r is 1. The next case. So a will become 3q plus 1. Again we'll cube both sides. Now here, those who have forgotten the identity, please note the identity. A plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square. This you did in class 9. But in case you have forgotten, you need to memorize this a plus b whole cube identity. Now I am going to use this identity here. So this will become a cube, that is 3q whole cube, 1 cube plus 3a square b plus 3ab square. So I am just going to solve this. So you will get 27q cube, 1, 3 square is 9, 9 into 3, 27. So this will become 27q square. And here 1 square is 1 itself. So 3 into 3 is 9q. Now I have underlined these 3 numbers because these are all going to be divisible by 9. So I'm going to take 9 common here. So here we get 3q cube, 3q square and q. And this I'm going to put in bracket, and this one I'm going to write separately. And this bracket now is replaced with m. So we get 9m plus 1. So we have proved that cube of a number can be in the format of 9m plus 1. Then the last case, Where r is 2, a will become 3 cube plus 2. Again, cube both sides. Again, we are applying the same identity. A plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square. 3 cube whole cube will become 27 q cube. 2 cube is 8. 3 square is 9. 9 3 is 27. 27 254 q square. Here we get 2 square 4. 4 3 is 12 and 12 3 is 36 q. Again, I have underlined these three numbers, so I can take 9 common in this. So we are left with 3q cube here, 6q square and 4q. And this plus 8 is written separately. The bracket is replaced with m and we get our answer 9m plus 8. So the value of m is 3q cube, 6q square and 4q. Okay. So in the first case we proved it is 9m. In the second case we proved 9m plus 1. Third case we proved 9m plus 8. So conclusion, cube of any positive integer can be in the form of 9m, 9m plus 1 or 9m plus 8. So both these questions, question number 4 and 5, please understand nicely and try to do these two questions on your own, because these are very important, and a question of this type also came in the board exam this time.